Okay, we're at Unit 4. We're on the Notes section. 4-1. We filled out 4-1, the first page on Friday, and so let's go to the second page here, where we're going to be factoring a trinomial that does not have a GCF. Okay. All right, so GCF means the greatest common factor. However, what does this word mean, trinomial? Well, here's what trinomial means. When we interpret that word, the prefix to a word tri means 3. So it means we're going to have 3 somethings involved. And nomial, when we interpret the word nomial, that means different terms. So trinomial, when you interpret it, it interprets as 3 different terms. And terms could be numbers, they could be variables, or they could be a combination of numbers and variables. So as you can see in my first example right here, we have this trinomial. The different terms are, we have the x squared term, which is different from the positive 8x term, which is different from the positive 7 term. So we have 3 different terms, x squared, 8x, 7. That makes this a trinomial. So here's how we factor trinomials. We're going to go over the process of what we do to factor trinomials. You're going to take the x squared part of the trinomial and put it in the upper left portion of the area model. You're going to take the part of the trinomial that has the x next to it, which is the positive 8x, and you're going to put that at the bottom of the diamond. You're going to take the part that is the positive 7, the part of the trinomial that does not have any variable at all next to it. Put that at the bottom right of your area model. And then you're going to multiply the x squared, which you put in the top left, with the positive 7, which you put at the bottom right of your area model. And that equals 7x squared. And whatever that result is, when you multiply those two terms together, you're going to put that up at the top of your diamond problem. So what we have done is we have created a diamond problem where the top of the diamond is 7x squared and the bottom of the diamond is 8x, and we are going to solve that diamond problem for the left and the right side, which would have to be a 7x and a 1x. Okay, why does that work? Well, 7x plus 1x, that is equal to my 8x, and 7x multiplied with 1x, that is equal to my 7x squared. Okay, so then once we find the left and the right of the diamond problem, we move those two results into the two empty spaces of the area model, 7x and 1x, into the upper right and lower left of the area model. Doesn't matter which one goes where. You could switch the 1x and the 7x spots. And now what we're going to do is we're going to find the outside parts of the area model, and those will be our factors. Okay, so let's start with the x squared box. So the only two terms that can multiply to make x squared are x times x. So I'm going to put an x on the outside of the top and the left of the x squared box. Then I'm going to follow that x from the top down to the 7x box. And the only value that I could multiply with x to get me the 7x box would be positive 7. So I put a positive 7 on the outside on the left of my area model. Follow that positive 7 on the outside on the left over to the 7 box. And then because 7 times 1, positive 1, is positive 7, I put a positive 1 up on the outside on the top. And to complete my area model, notice that x times 1 is equal to 1x, okay? So what this tells me is that my factors are x plus 1 and x plus 7. And the way that I write that when I get to my factored form of the given trinomial, I put a parentheses, and inside the parentheses, I put my factor from the outside on the top of the area model, which is x plus 1, close that parentheses, start a new parentheses, and in the second, and then fill in there the x plus 7, which is the factor which is on the outside on the left. Okay, so my factored form of my given trinomial, x squared plus 7x plus 8, is x plus 1 multiplied with x plus 7. Okay, so notice that this trinomial has two factors, x plus 1 and x plus 7. And remember, the way that factoring works is, if I multiplied x plus 1 out with x plus 7, it would give me the inside part of my area model, which is equal to x squared plus 7x plus 8. So it's all kind of connected. Moving to the next trinomial, my given trinomial is, I have an x squared term. I'm going to put that term in the upper left portion of my area model. I have the positive 4x term, and I'm going to put that in the bottom of my diamond problem. Then I have the minus 12 portion, so I'm going to put a negative 12 in the bottom right of my area model. And then I take my x squared, I multiply it with the negative 12, and that result gives me x squared times negative 12. That is equal to negative 12x squared. So I put that result, that negative 12x squared, up at the top of my diamond problem. So I've created this diamond problem now where the top is negative 12x squared, the bottom is 4x. So I solve the left and the right side, and that would be the way to solve it. I would have to have a positive 6x and a negative 2x, okay? 6x plus negative 2x is equal to 4x, which is the bottom of my diamond problem. So that works for me. And 6x multiplied with negative 2x, that is equal to the negative 12x squared, which is the top of my diamond problem. I take the 6x and the negative 2x and I move them over into the two empty spots in my area model. And now I fill out the top, outside, and left of my area model, and those will be my factored form. Start with the x squared box. Always start with that upper left box. X times x are the only terms that are going to multiply to make x squared, so I put an x and then x on the outside of the x squared box. Follow the x from the outside top down to the 6x box. You would have to multiply positive 6 with that x to give you the 6x, so I put a positive 6 on the outside left of my area model. Follow the positive 6 over to the negative 12 box. Because 6 times negative 2 gives me negative 12, that means I put a negative 2 on the outside top of my area model. And then to complete my area model, x multiplied with negative 2 gives me my negative 2x. So that means my factors are x minus 2 is one of my factors, and my other factor is x plus 6. And the way that I write that in factored form is I put a parentheses, put an x minus 2 in the parentheses and close it, start another parentheses and put the x plus 6 in the other parentheses. So notice that my factors, I have two factors once again, and those two factors come from what are on the outside top and outside left of my area model. Third example, my given trinomial is x squared minus 13x plus 40. I'm going to take the x squared portion of my trinomial, and I'm going to put that in the upper left of my area model. Then I'm going to take the term negative 13x, the term that has the x with it, that goes at the bottom of my diamond problem. So negative 13x at the bottom of my diamond problem. Then I'm going to take the term of the trinomial that does not have a variable next to it, which is positive 40, and I put that at the bottom right box of my area model. My next step is to multiply the two pieces together in my area model. In other words, multiply x squared with positive 40. Write that result down, which is equal to 40x squared. and I put that 40x squared, the result, at the top of my diamond problem. And now I solve my diamond problem, which has a 40x squared at the top and a negative 13x at the bottom, which would mean that I would solve it with a negative 8x and a negative 5x on the left and the right. And it doesn't matter if you put the negative 5x on the left and the negative 8x on the right. Move the negative 8x and the negative 5x over to your two empty spots of your area model. And now solve the area model for the outside on the top and the outside on the left, always starting with the x squared box. Because x times x gives me x squared, that means I'm going to put an x on the outside of the x squared part of the area model. Follow the x from the outside on the top down to the negative 8 box. You would have to multiply negative 8 with that x to give you the negative 8x, so put a negative 8 on the outside on the left of your area model. Follow that negative 8 over to the positive 40 box, and you would have to multiply negative 5 with negative 8 to give you that positive 40, so you put a negative 5 on the outside on the top of your area model. And then to complete the area model, x multiplied with negative 5 gives you your negative 5 box. So your two factors are going to be x minus 5 and x minus 8. And you write those two factors in the form of parentheses. So start a parentheses, put the first factor, which is x minus 5, in that parentheses and close it. Start a new parentheses and put the other factor, which is x minus 8, in the other parentheses, okay? So what this is telling me is that the trinomial x squared minus 13x plus 40, it factors into x minus 5 multiplied with x minus 8. Last example, we have the trinomial 3x squared minus 4x plus 8 minus 8x plus 4. We're going to factor that trinomial. So how do we do it? Well, we take the term that has the x squared in it, which is a 3x squared this time. This is the first one we've done where the x squared portion, the x squared term, has a number in front of it. But we put that 3x squared in the upper left part of the area model. Take the term that has the x in it, which is minus 8x in this trinomial. Put that at the bottom of your diamond. Take the term that does not have a variable next to it, which is a positive 4. Put that term in the bottom right of your area model. Then you're going to multiply the two terms in your area model together. So in other words, you're going to multiply 3x squared with 4. And that result is equal to 12x squared. You need that result. And the reason why you need that result is because you put that 12x squared at the top of your diamond problem. So you have now created a diamond problem with a 12x squared on the top, a negative 8x on the bottom, and you solved the diamond problem, which would have to be a negative 6x and a negative 2x. Okay, move that negative 6x and the negative 2x into the two empty spots of your area model. And now we solve the area model by filling out the outside on the top and the outside on the left, which will be my factors. Let's start with the 3x squared. Well, the two terms that multiply to make 3x squared are 3x times x. So I'm going to put a 3x either on the top or the left of my 3x squared box, okay? I'm going to put the 3x on the top, and I'm going to put the x on the side, and here's why. When I follow the 3x down to the negative 6x box, I could multiply negative 2 with that 3x to get negative 6x. So putting the 3x on the top allows me to fill out this bottom left box of the area model. So I put a negative 2 on the outside on the left. Take that negative 2, bring it over to the 4 box of your area model. you would have to multiply -2 with that -2 to get +4. So you put a -2 on the outside on the top of your area model. And then filling out the area model, the outside left x times that -2 on the outside top, that gives you -2x box inside your area model. So your two factors are 3x minus 2 and x minus 8. And then to write that in factored form, you do a parentheses, put the outside top inside that parentheses, 3x minus 2, close that parentheses up, start a new parentheses and put your other factor, which is the outside left, x minus 2 in that parentheses, and close that up. So what is this telling me? Well, this is telling me that if I took the given trinomial 3x squared minus 8x plus 4, it is equal to the factored form of 3x minus 2 times x minus 2. These two expressions are equivalent with each other, okay? With each other. So this is what factoring is telling me, that you need to find two expressions, 3x minus 2 and x minus 2, that when you multiply them together, it's going to be equivalent to the given expression. And there we go. There's factoring, how to factor a trinomial when we do not have a greatest common factor, a GCF. Section 4-1, second page of the